Okay, so we've got the
So
power supply
here's
set
what
on
we have a
12
little
volts.
closer.
This is the
Going
one
into
stator motor
the
that we were
SSG
running
circuit. I have a
on the other
bulb hooked
video
up
with
to the
the
output
Dremel tool.
because there will be some high voltage.
This time we're running it with the
And
window.
You're in my way, buddy. You're in my way. You gonna help Daddy? Okay. I'll try to work around you.
Oh, I always wanted to do this. Okay, I have here the same parts that I use for the video on Bedini high voltage without a DC power supply. How does this look? And I'll just set this down. I feel too silly with it. So here's the same motor that I used on the high voltage video. And I'm going to run it for a while on this window motor. I was using a Dremel before, as if you remember on the video. This way we'll keep some constant RPMs on the motor. And I'll take some measurements from it, and we'll look at how it operates as a generator. And the purpose of the video is that somewhere down the line I hope to clear things up a little bit. The other video was really confusing, and I apologize for that. So on this one we'll just go over some of that material again, if you don't mind watching and waiting and going through a long video. But we'll look at the window motor, running the stator motor as a generator. Then we'll look at the difference of running the Bedini SSG circuit, or simplified schoolgirl circuit, from a pulse circuit as opposed to mechanical oscillator circuit. And I hope to clear things up as to whether this is a motor, a generator, or a mechanical oscillator. Maybe by the time we're finished you'll say you can call it any of the three. So let me get some things ready and we'll get started. Well, first of all, we'll start looking at the components, and I'll try to explain them a little bit so that those who aren't familiar with the Bedini patents or his little circuits and what he intended them to do will understand a little bit better. So let me get something ready and we'll talk about it. So here's what we have a little closer. This is the one stator motor that we were running on the other video with the Dremel tool. This time we're running it with the window motor. The power for the window motor is 12 volts from the Lambda power supply. And we're using the Bedini full wave bipolar circuit to run the window motor, although I'm only using one trigger, therefore half the circuit. We have the Bedini SSG circuit over here, and if you remember right, we've hooked this motor, generator, oscillator, whatever, to that circuit and ran high voltage spikes off the circuit and coils while turning this mechanically, as opposed to having a battery plugged into the SSG circuit, which would have been over here. So we're going to go back to that experiment later, but let me talk about the motors a little bit first. This is what these motors look like if you pull them off an office machine, or if you order them online. You can find these online if you type in a search for printer motors or office machine motors, printer drive motors, printer mains motors, anything like that, and you'll find these motors. I've seen them as low as $4. So what they have is a typical sort of an outrunner, like you see on a model airplane motor. They usually have some drive circuitry on them. These chips happen to be a NPN and PNP FET driver circuit, and there's usually some other components on there. But anyhow, these are, let's see, let me go back to something else. When you start to take them apart, you get something that looks like this: a stator, a little casting here that holds bearings, and you can see that you almost already have a motor mount on there. I like these green ones because they have thin legs and you can wind a lot of wire around them, as you can see. The magnets for these are like a solid ring magnet around here, and they're actually 8 poles, 4 north and 4 south, if you measure them. So it's an 8-pole brushless motor. The way these motors actually work is there's some Hall effect sensors on the boards underneath the magnets. So they allow the motor to run in this 3-phase operation. If you look at the way the coils are wound, they're in a typical 3-phase configuration. You take one of these apart. It's hard to work with one hand. But this is what the windings look like on the stock motor. You can see under here somewhere there's some Hall effect sensors. I don't know if you can see one under there or not. I think you can. But there's 3. Looking at the back of the board, we can see the 3 beginning of the phases. This would be the beginning winding of each of the 3 phases. And over here we can see that each end of the 3 phases is tied together. So that indicates that this motor is in a Y or star configuration. And so it'll run as a 3-phase motor if you can figure out a way to do it. Now you can do that with a regular RC brushless motor control. So if you take those 3 wires, attach them to those 3 phases, get yourself a little servo tester here to run the speed control, you can run this as a brushless motor the way you would a model airplane motor. And I'm going to make a video about that at some other time, so I don't want to go into that too much. I'll pick some other motor and try to make something useful. There's some other things you can do with these motors. Here I've actually made some connections to the Hall effect sensors that are under the rotor. So what I did is actually use the Hall effect sensor along with the John Bedini circuit and ran the motor that way. So there's a lot of things you can experiment with. The motors come in a lot of different sizes, shapes, forms. There's some pretty good size ones. That's a big one. And some of them even have gearboxes on them. Now what I usually do is melt this soft ring magnet off of here and replace it with something that looks more like this. And from there we're going to go on to trying out one of these motors and see what we have. So we'll get this running and hooked up and talk about that. I want to explain what started this whole experiment. At one time there was a lot of people on the forums taking these fans apart or buying a kit and rewinding this stator in here to work with the SSG circuit or a modified circuit of that, and they were making their little energizers or chargers or pulse motors this way. So I thought I'd try it, but the first thing I did was lose the bearing in the center, so I wasn't going to pick up another fan. So what I did was I had these other things, so I took one of these larger stator motors and I wound 4 of the legs similar to a fan motor. And that worked, so I thought, well, I sure would like to see if I could do it with all the legs. So that's how this started. I decided that I was going to do whatever I could to get one of these stators to work with all 12 legs wound. And the way I did that was the way I explained with trigger circuit and then the power coils. So to start this all off, I wanted to make a modified version of this and actually see if I could make a motor that would run from this little Bedini energizer circuit or pulse circuit. And so let's hook something up here and we'll take a look at it. Okay, so we've got the power supply set on 12 volts. Going into the SSG circuit, I have a bulb hooked up to the output because there will be some high voltage. And let's spin her up. Alright, so there you go. It's running up around somewhere between 3,000 and 4,000 RPMs.